Hello and welcome back to another Orange Coast College Mathematics video. In this video, we're going to be talking about different logarithm properties. So let's go ahead and jump right into it. So there are three properties that we're going to be focusing on. There's the product property, the quotient property, and the power property. Now the product property says if I have the logarithm of a product, I can actually separate that product as the logarithm of the first thing plus the logarithm of the second thing. Now both of these will inherit the same base from the original logarithm. The quotient property says if I have a logarithm of a quotient of x divided by y, then I can separate this as log of the numerator minus log of the denominator. And again, both of these logarithms will inherit the same base from the original logarithm. And last but not least, we have the power property. The power property says that if I have a logarithm of something to a power, what I can do is I can take that power and I can drag it down and multiply it in front instead of having it in the power. So log base b of x to the p power becomes p times log base b of x. So with these in mind, let's go ahead and try some problems. So for each of these following problems, we want to expand our logarithm as much as we can. So let's go ahead and use our properties to expand number one. So first off, we have log base b of 3 times x times y. So we can go ahead and separate this. It'll be log base b of 3 plus log base b of x, and then plus log base b of y. So let's go ahead and try number two. So number two, we can see clearly that there's a fraction in here. So we're going to want to use our quotient property. So this is going to become natural log of the numerator and then minus natural log of the denominator, y times z. Now we notice that I have a logarithm of something to a power. And so I know that I can drag this power down in front. I also see that this is a y times z, so this is a product, and so we can separate that as well. So this 3 is going to go down in front, and this is going to become 3 times natural log of x, and then minus, however, we have to be careful here, put parentheses around this. We'll have natural log of y plus natural log of z. This negative sign is then going to distribute to each piece in here, and so we'll get a final answer of 3 times natural log x minus natural log y minus natural log z. Let's go ahead and check out number 3. So again, we can see that we're going to be dealing with a fraction, so we know we're going to have to split it up. So this is going to become log base 7 of the numerator, so 49x squared times z plus 1, and then minus log base 7 of the denominator, so 5 times y cubed. Now we see that there's a lot of multiplication going on inside of each of these logarithms, and so we can separate them out. We have a 49, an x squared, and a z plus 1, and then we have a 5 and a y cubed. So this is going to become log base 7 of 49, and then plus log base 7 of x squared, and then plus log base 7 of z plus 1, and then minus log base 7 of 5 plus log base 7 of y cubed. Now we see there's going to be some exponents in here that we can drag down in front, so this 2 goes there, and this 3 is going to go down in front over here. We also need to take note that this negative sign is going to distribute to both of these pieces. And then finally, we can note that log base 7 of 49 is going to be equal to 2 because 7 squared is equal to 49. So this then becomes 2 plus 2 times log base 7 of x plus log base 7 of z plus 1 minus log base 7 of 5 minus 3 times log base 7 of y. And this is our final answer. One thing you should be wary of, though, is that if you see a sum inside of a logarithm, you cannot separate it using the product rule. That is only for products, so x times y or z times 5. This right here is z plus 1, and so we can't actually separate it, though it is tempting. So let's go ahead and move on down to the next problems. For these problems, we want to condense everything into a single logarithm. So to start off number 4, I see that there's a constant in front of here, and I can actually drag this over here and turn it into the exponent. If I do, we're going to have log base b of x plus log base b of x minus 1 to the 4th power. Now that I don't have any constants in front of these logarithms, I can combine them using the product property. And so this then becomes log base b of x times x minus 1 to the 4th power. And now everything is in a single logarithm, and so we're happy. Let's go ahead and check out number 5. Right away we can see there are some constants in front, and so I can drag those into the exponents. And so this then becomes log of x squared minus log of x plus 1 quantity cubed. This becomes log of x squared divided by x plus 1 quantity cubed. And so we've combined everything into a single logarithm. Let's check out number 6. Again, we see some constants out front that we can drag into our exponents. This then becomes natural log of 5 plus natural log of x cubed minus natural log of y squared minus natural log of z. Now from here, I notice that both of these have a minus sign, and so I can factor a negative out. So we get natural log of 5 plus natural log of x cubed, and then minus the quantity, natural log of y squared plus natural log of z. Now I see that I have two logarithms being added together, so I can use a product property, and then I can also use the product property for these ones in here. This then becomes natural log of 5x cubed minus natural log of y squared times z. We then see we have a difference of two logarithms, and so we can put them into a quotient. And so our final answer becomes the natural log of 5x cubed divided by y squared times z. Let's go on down to number 7. So for this one, we see there's a constant out front that we can drag into an exponent. So this becomes log base 5 of x squared minus 1 minus log base 5 of x plus 1 quantity squared. There's a difference of two logarithms, so we can combine it into a fraction. This becomes log base 5 of x squared minus 1 divided by x plus 1 quantity squared. Now we can actually simplify this a little bit more. X squared minus 1 is a difference of two squares. And so this is going to become log base 5 of x minus 1 times x plus 1 divided by x plus 1 quantity squared. The x plus 1 in the numerator is going to cancel out with one of them in the denominator, and so we're left with log base 5 of x minus 1 divided by x plus 1. And that is our final answer. Well, that's going to do it for this video, and I hope to see you in the next one.